Okay, here we go. Time to start a new chapter. We are going to start looking at matrices. And if you look here, a couple of ideas. What is a matrix? Okay, well, we're not talking about the movie with Keanu Reeves or anything, but we are talking about a mathematical matrix, which is a rectangular array or table of numbers, symbols, or expressions arranged in rows and columns. And if you look, some things that matrices are used for, like real life kind of a things, linear transformations, graphics, science of optics to account for reflection and refraction, all kinds of times that you can actually use matrices, in real life. Okay, so what is a matrix? We kind of talked about that. Here's what they actually look like. Matrices, down here on the bottom, I've got that 9 with, looks like the square brackets that we did when we were doing intervals. It is a square bracket that indicates that it's a matrix, and we should have brackets around all of these like that, but to be quite honest, when I was making my Google Doc, I couldn't figure out how to get all of the numbers in the brackets, so we are just going to add the brackets in later. So the dimensions of a matrix is described as a, like a 2 by 4 is 2 inches by 4 inches. A matrix is described in the same way. It's the number of rows times the number of columns. So the number of rows comes first, number of columns comes second. So this one would be a 1 by 1 matrix. And then if you look at the second one there, it's got 2 rows, 3 columns, so it would be a 2 by 3 matrix. And then here, this one on the bottom, we have 1, 2, 3, 4 rows and 3 columns, so it would be a 4 by 3 matrix. So when we start talking about dimensions and things like that, and when you can use certain matrices, that's what we're talking about. Okay, so we're going to just start with basic operations with matrices and scalar multiplication, which is just like the distribution property. So in order to add or subtract your matrices, they have to have the same dimensions. So this guy here is a 2 by 2. This guy here, also a 2 by 2, which means you can add them together. And all you do to add them together or subtract them is basically just find their corresponding parts, right? So this one and those two correspond. These two correspond to each other. These two correspond to each other. And then these two correspond. First thing we're going to do down here is we are going to do A plus B. So if we're doing A plus B, that means we're taking our matrix -1, 2, 0, 1, and we are adding it to the matrix 1, 3, -1, 2. And when we put them together, we will end up with a 2 by 2 matrix. And again, all we are doing is we're just putting those two together. -1 plus 1 is 0. Okay, and then we have 2 plus 3 is, oops, I meant to do that in a pen, is 5. And then moving on, and oops, I did the wrong color there. Let's fix that really quick. So this one should be, oh, I have those two colors switched. So anyway, those two colors are switched, but we should have in green, we've got this guy and this guy. 0 plus -1 is going to be -1. And then the last one, 2 plus 1, that's a 3, is 3. So when we add those two matrices together, we get 0, 5, 1, -1, 3. Okay, moving on to the next one. Now we are going to do B minus A. So B minus A, make sure you do them in the right order because with subtraction, the order matters. So B is our matrix 1, 3, -1, 2, minus A is -1, 2, 0, 1, and our solution is going to be a 2 by 2 matrix, and we are going to subtract, remember, so we're going to take 1 minus -1, which is going to be 1 plus 1, which is 2. Then we're going to take 3 minus 2, which is 1. Then we're going to take -1 minus 0, which is just going to be -1. And then we're going to take 2 minus 1, which is just 1. So our solution is going to be 2, 1, negative 1, 1. And then the last thing is what's called, so this is adding and subtracting. This is what is called scalar multiplication. Okay, which is basically just like the distributive property, which we've done a lot of. It's very simple to do. So if we're taking 4 times a, we're going to take 4 times, well, our a is negative 1, 2, 0, 1. And we are just basically multiplying every part of it times 4. So we're going to get negative 4. 4 times 2 is 8. 4 times 0 is 0. 4 times 1 is 4. So that's how you do scalar multiplication, adding, and subtracting. And then the last thing we're going to look at today is solving matrices with an equation. Okay, so we have two matrices. We've got A and B here. And again, I'm going to put them in their brackets here so we know we're talking about a matrix. And we are going to solve the problem 3x plus A equals B. Okay, and we're solving for x. We want x by itself. So that means we're going to take 3x. Okay, we're not going to do any dividing anything just yet. Plus A. We know A is the matrix 1, negative 2, 0, 3. And it is going to equal B, which is negative 3, 4, 2, and 1. Okay, and we solve these essentially exactly like you would solve anything else. Okay, so in order to get 3x by itself, we are going to subtract this matrix. I'm going to kind of write it a little bit smaller here because I don't have a ton of room. 1, negative 2, 0, 3. We're going to subtract that just like we would, and those are going to cancel out here. And then we're going to subtract the same thing on this side. So we're going to subtract 1, negative 2, 0, 3. Right? We're going to get 3x equals, well, if we subtract these, negative 3 minus 1 is negative 4. 4 minus negative 2 is 4 plus 2, which is 6. 2 minus 0 is just 2. And then 1 minus 3 is negative 2. Okay, and then I'm going to have to sneak in just a little bit here because I'm going to have to divide by 3, which is the same as multiplying by 1/3. So basically, kind of like we did scalar multiplication, if I divide everything by 3, I'm basically going to take everything that is in here, and we're going to have it divided by 3. So negative 4/3. 6 divided by 3 is 2. 2 divided by 3 is 2/3. And negative 2 divided by 3 is negative 2/3. So it follows the same idea as solving equations, just algebraic equations, but it looks a little bit different just because it has matrices in it. So I'm just going to show you another way to think about this. So I showed the work with the matrices substituted in first. You can also, I'm going to show you just another way that gets you to the same ends. Okay, and that would be I have 2x minus a equals b. If I want x by itself, I'm going to add a to both sides. So I can do some of this ahead of time. So I have 2x equals b plus a. I don't want to divide anything by 2 just yet. So I'm going to do 2x equals b, which is 4, negative 1, negative 2, 5, plus a, which is 6, 1, 0, 3. Okay, so then I'm going to have 2x equals, I'm going to add my corresponding pieces. So I'm going to have a 2 by 2 matrix. I'm going to have 10, negative 1 plus 1 is 0, negative 2 plus 0 is negative 2, 5 plus 3 is 8. And then if I divide everything by 2, I'm going to get 10 divided by 2 is 5, 0 divided by 2 is 0, negative 2 divided by 2 is negative 1, and 8 divided by 2 is 4. So in the first example that I did, I substituted the matrices first and then did my operation, my inverse operations to get x by itself. In the second example, I moved the variables a and b first and then I substituted, either way is just fine and they both will work. And this is the end of day 1's notes. There is a worksheet called Matrix Operations in Schoology that you can work on, and it needs to be submitted when you are finished.